6.1 Part 2, Comparing Forms of Quadratic Relations. Okay, there are three forms of the quadratic relation that give us different information to help us graph each relation. Okay, so if we're given factored form, what we're given here is the two factors, so the two x-intercepts, whatever they are. Okay, so they'll lie on the x-axis, and then what we can find with that is we can find the axis of symmetry, and then of course plug in another point to see if it opens up or down. Okay, but we're given two x-intercepts. Now standard form actually only gives us the y-intercept. Okay, because if you sub in x equals 0, the y-intercept is c. Oh, and the two x-intercepts are r and s. Okay, with the standard form, we're able to go to factored form by factoring, and then vertex form by completing the square. Okay, and vertex form, we're given the vertex, which is h comma k. Now, if we want to change between forms, okay, so I'm going to kind of make a pattern of this. So first of all, we always have to start with standard form. Okay, so if you want to go from factored to standard, okay, so this way, we need to expand. But also, if we want to go from vertex to standard, we need to expand. Okay, so factor, and anything going to standard, we expand the whole thing because we know standard is completely expanded form, x squared plus bx plus c. Okay, full, there's nothing factored in here. Now, if we want to go from standard to vertex, we know that we have to complete the square, and then standard to factored form, we just simply have to factor. Okay, so we can go from one form to the other, no problem, we just have to know how to. Okay, standard form being that middle ground. So let's go ahead and flip-flop between different forms. So a parabola has the zeros -3 and 7 and passes through this point. So first what we're going to do is we're going to write the equation in factored form, which is pretty easy because it gives us the two factors. Okay, so I might have to do this on the side of the paper or carry on to the side. So the only thing that we don't know is the a value, which is like the stretch factor. Okay, so let's go ahead and sub in x and y, and then r and s. Okay, so the y is 36 equals a. We don't know a. X is 5. So in both of these brackets, it's going to start with 5. And then we know if the actual x-intercept is -3, then this is +3. If it's 7, then this is -7. Okay, so I get 36 equals, we get 8, and then we get -2, which is -16. Bring this up. Okay, so we have 36 over -16 equals -16a over -16. And if we reduce that, we get 9 over 4, -9 over 4. Okay, so a equals -9 over 4. So when it actually asks us for like the full equation, we need to actually write y equals -9 over 4, bracket x plus 3, bracket x minus 7. Now we have this equation in factored form. Let's go to the middle grounds. Let's go to standard form. Okay, so let's go y equals -9 over 4, x plus 3, x minus 7. What we're going to do is we're going to expand this, so we're going to FOIL it. Okay, let's leave the -9 over 4 and let's just expand the middle two terms. Okay, so x squared minus 7x plus 3x minus 21. Okay, let's collect these two middle terms. So this simplifies to x squared minus 4x minus 21. Now, let's expand that -9 over 4. So -9 over 4x squared, and then when we multiply it by this, we get positive 9x, and then when we multiply it by 21, so -9 times negative 21 divided by 4. We get 189 over 4. I guess we can put it as a decimal because this one's not going to change. So positive 47.25. Okay, now we're going to take this and we're going to write it into vertex form, and I'm just going to use my space here wisely, okay? So what we're going to first do is group the first two terms, and we're going to actually pull out a negative 9 over 4. Okay, so those go away. We get y equals negative 9 over 4, and then in the bracket we get x squared. And if we divide 9 divided by negative 9 over 4, we actually get negative 4. That's a really nice number. Okay, so negative 4x. And then this is okay as a decimal because we're not working with it, so that's fine. And it stops at 2 decimals. Let's take this 4, let's divide it by 2, and let's square it. So 4 divided by 2 is 2, squared is back to 4. So inside this bracket, we are going to write plus 4 minus 4. And everything else stays the same. Now, when we take this negative 4 out of the bracket, we multiply by negative 9 over 4. So let's just rewrite. We have y equals negative 9 over 4. We're going to have a trinomial here, x squared minus 4x plus 4. Okay, and then if we multiply negative 4 times negative 9 over 4, negative 4 times negative 9 over 4, we get 9. That's what I thought. So we get plus 47.25 and then plus 9. Okay, if we were to factor this, we get y equals negative 9 over 4, x plus 2 squared. And then if we add these two, we get 56.25. Okay, and that's how you go from factored to standard. So you can never go from factored to vertex, and you can never go directly. You have to have standard form as that middle ground. Okay, example 2. So it asks us to graph. So when we're given something like this, we have to actually recognize what form is this in, what information does this give us. Okay, this is in factored form. It gives us the two factors. We get x equals 1, and then we get x equals negative 2. We can go ahead and plot those as the x-intercepts. Okay, so 1 is here, negative 2 is here. If we wanted to find the axis of symmetry, we would just add those up, so average them out and divide them by 2. So 1 minus 2, negative 1/2. So this would be our axis of symmetry, which is fine. Okay, the only other point that I would plot here is the actual vertex itself. So we can take this axis of symmetry and we can sub it into the original. So negative 1/2 minus 1, and then we have negative 1/2 plus 2. Okay, so y equals 2, negative 1.5, and then this is 1.5. And if you solve this on your calculator, you get negative 4.5. Okay, so on that axis of symmetry, negative 4.5. This gives us the 2 points, kind of using symmetry because they're x-intercepts, so they're going to be symmetric about the axis of symmetry. And then we also graph the vertex. So that's pretty easy. Now, this example, it asks us to graph again. The only thing is that this is now in expanded form. So the only piece of information that this actually gives us is if we subbed in 0 for x, it gives us the y-intercept. So the y-intercept is going to be negative 12. Okay, this doesn't look like anything so far. So I would actually take that and I would see if we could factor it. Okay, I find factoring quicker than completing the square, but you can do either one. Okay, just let's find out a couple more pieces of information. So what two numbers, a little blast from the past for the factoring, okay? what two numbers multiply to negative 12 and add to negative 4? Okay, so we have 1 and 12, 2 and 6, 3 and 4. And the ones that add to negative 4 are 2 and negative 6. So those are the factors. We have x plus 2, x minus 6. Okay, so if you wanted to plot the y-intercepts, they're going to be negative 2 and 6. So negative 2 and 6. Okay, so if you want to find the axis of symmetry, I would do negative 2 plus 6, and I would average these out. So 4 over 2 is 2. So this here would be the axis of symmetry. And now I'd actually want to find the vertex. So let's just sub in 2 to where the x's are. So I get 4 minus 8 minus 12. So this is negative 20. So I get negative 16. So on that axis of symmetry, which is 2, it occurs at negative 16. And then you go ahead and you label your graph. So example 4, we're going to graph this equation. So we know that this is in vertex form. So our vertex is going to be, here we go, negative 1 comma 4. Okay, so negative 1 comma 4. And if we graph this on our graph, we get it right here, comma positive 4. There we go. So this is easy because it's in vertex form. We're going to plot a point 2 units to the left and 2 units to the right. So I'm going to choose to sub in 1 just because it's an easier number than negative 3, but you can sub in either number and you will get the same answer since parabolas are symmetric. Okay, so negative 2, and then we have 2 squared plus 4, and we have negative 2 times 4 plus 4, so we have negative 8 plus 4, which gives us negative 4. So at 1, we would plot negative 4, and at negative 3, we would also plot negative 4, and there is our parabola. And let's just label it y equals negative 2x plus 1 squared plus 4. Okay, example 5, write the quadratic relation in standard form and then factored form. So we're going to go from vertex form, and in order to go to standard form, we have to expand. So if we have x plus 1 squared, we're going to rewrite it as x plus 1, x plus 1. Okay, and we're going to go ahead and factor that, or sorry, expand this. X squared plus x plus 1, and we just carry down that negative 9. So now let's collect like terms. We get x equals x squared plus 2x minus 8. Here is our standard form. Now factored form. All we have to do is we have to take this equation in standard form, and we have to find two numbers that multiply to negative 8 and add to 2. Well, the factors of 8 are 1, 8, 2, and 4. So 2 and 4 are going to add to 2, and the negative 1 is going to be on the 2. So y equals x minus 2, x plus 4 would be our factored form. Okay, again, going from vertex form, we have to go to the middleman, which is standard form, and then to factored form.